So in this video I'm going to look at this Shannon Tweezer. This is a SMD tweezer. It does quite a bit. I've played with them a little bit. So this has been given to me at no cost for the purpose of review. So thank you very much, Shannon, for sending this to me. That was much appreciated. Stick around and find out what the review looks like. So this particular kit, there's different versions you can buy. This one comes with a little leather holster to put it into to store it if you're not going to use the case. There's a little calibration board here, which you also use for doing verification, just to make sure it's working correctly if you want to. It's got a bunch of capacitors and stuff like that on it, resistors and inductors, diode. So you can do some calibration of the actual tweezer, like a user cal on it. So we also have, in the box, we have a charging cable here, which is USB-C. I'm just going to leave that in there for the time being. And obviously the tweezer itself. Now I also have this. I'm going to look at it now and get out of the way because it's affecting the brightness on the screen. As you can see, it's just like a quick start guide, how to navigate with the joystick, what menu systems there are, something to show some of the menus in here. And it's also got options when you're in the top level where you're just using the tweezer. You can move the joystick around and then go straight into certain functions. And on the back here is the actual menu structure, maybe the front, not the back, I don't know. But it tells you the menu structure so you can find things quickly if you need to. Although it is pretty easy to navigate the menu structure. Yeah, it's simple really. And here's a close look at the calibration board. So you also see it's got opens and shorts and stuff on it as well, just down here. So it's 0.1% resistors. And that's what it's got on the back. Upside down. Information about how to use it. So, the tweezer itself. I've already charged this up. My tinkering with it so far has been really rudimentary. I haven't done a lot with it yet, but I've done some, just trying to figure out how to use it a little bit. It's not something I normally do. I'd normally get something and show you as you would find it if you're trying to sort of figure out how to use it kind of thing. I normally show that. But in this case, I wanted to do a bit better than that. So, first impressions, let's look at the physical aspects. Really nice enclosure. It's small, compact. Same thing. Nice broad tweezers. Fit in my hand really easily. It's a nice comfortable fit. It's got these anti-slip grip things up here which also slightly tapered outwards. You can see that on there or not. You can see they come out slightly so you don't slip downwards. These are really easy to squeeze together, right? So no issues at all. Squeezing those together, no problem. These have got gold plated tips on them and they come up together really nicely. I think there was a little bit of adjustment in them as well. Mine are basically right. Some tweezer things, right? I've got some other ones here which I might show you actually. These ones, which is just for comparison. You can actually you can twist the tweezer part and affect the alignment. So if you're trying to pick up a small part or measure a small part, you might find that it will ping off because it twists and it's not good. These, on the other hand, are nice and rigid. I'm not having any problems with that at all. There's no real twist in them, they feel good. So let's actually turn the things on. Hold it down for a second. It goes. So my battery is almost fully charged. I've charged it up and used it a little bit. I haven't changed any default settings on this. I don't think I was playing around with it before, but I don't remember if I've changed any default settings. Let's get a close look at the screen. Well, you can see it's showing quite a bit of information already. It's showing it's got the beeper, and it's also got like a volume dot there to show how loud it is. It's showing it's doing series resistance. It also shows an RS up here as well. In capacitance mode at 100 Hz with a 0.5 volt test voltage. So if I do the cursor upwards, that changes the frequency. So 10 kHz, and that's on auto now, which is 10 kHz auto, right back to 100 Hz. So I prefer 100 Hz as my test frequency. Don't know show that stuff yet. And if I go down with the cursor, that changes this voltage. So if you go downwards, it changes this voltage here. So it's got 0.1 volts, which is good for doing in-circuit testing, so you're not triggering any silicon or Schottky diodes, that sort of stuff. Any kind of junctions, that should help avoid that. Go down again, you've got half a volt, and down again you've got 1 volt. So those are the 3 test voltages you can test at. Now this is just floating around in auto mode right now, so it will see all kinds of things changing around, so don't worry about it right now. Now I've also got the left and right joystick options, which basically goes through the different functions. So resistance DC, so DC resistance. You've got diode, LED, diode, junctions, ESI measurement, so series capacitance, see? You got the frequency and the voltage adjustment on that one. Was that reactance? I don't know. Anyway, you can change these sub-venues as well. And capacitance. Inductance here. Standard resistance, parallel capacitance there. And auto mode again. So if I close these now, that'll measure resistance. And doing the cursor the other way just does the same thing but in the opposite direction. So the menus, let's go in there, got some fluff on the screen. So there's quick set, go into there, so you got auto now, which is auto mode, sec para, so second parameter, and then choose auto resistance or D or Q. Right, so I tend to leave that on auto at the moment. I haven't really used it that much, so I'm not sure which I actually use yet. And when you do go in and out of the menu, it will go back to the last one you used as well, which is quite handy. So this will actually automatically exit after a certain period of time, so it's dropped out. So if you use a certain menu, you want to go back into there, you can just leave it, it will drop back out again. When you go back in, it will go back to it. Model, which means series and parallel. I call serial, I'm not sure, it should be serial or series, not sure. Give me your opinion down below in the comments. You think it should be serial or series? Anyway, you want auto for now. So system, so you've got sound level, so you turn it on down and on off, and you can also adjust the level as well if you want. Just going to leave it on, back into there, so you've been back to the same menu again. Timeout, so it's set for 30-second timeout right now. You can change it. Right, so obviously the longer you leave it, the better it could be for you, but I'm going to use 30 seconds for now. That's what I'm doing. So display, you can do left to right handed, so obviously right now it's set for right handed right now. If I change the left handed it will flip it over, so if you're left handed it will flip the orientation around. Contrast measurement, or contrast adjustment, obviously then exiting as well. We'll go down to the next one, measurements, modes, auto LCR, inductance, capacitance, so you can choose which mode you want to basically default to. Right, so you can choose which one you want. For me, I actually want just to have an auto LCR all the time. I'm happy with that. There's other stuff in here. Frequency, so it's default frequency. This is set to automatic, I think, right now. So 10 kHz, 1 kHz, 120 Hz are the defaults. I'm not sure why it says 120 and not 100. I'm not quite sure what the difference is there. I don't know. Anyway, maybe there's something more to it than that which I haven't identified yet. Back to measure again. So level. This is the default levels. So I think 0.1 volts is better. I think the higher the voltage, the more accurate capacitance reading will be. Some of that, I'm not quite sure. Haven't really played around with that yet. Speed, measuring speed, so fast, medium, slow. Now one thing it doesn't actually show is what it currently is set to. It would be nice if it did that. So maybe if you had like a little indicator, say it's on this one, or maybe highlighted. Maybe it's because you've got this arrow and highlighting, maybe the highlighting should be the current mode and the arrow should be the one you're trying to change to, maybe. You know, as the cursor. You know, I mean, I'm assuming it's on fast. I think it is. What else we got in here? Holding as well, so you can do auto holding. If I turn it on, it will hold the display until it gets a reading. And it'll actually beep a little bit as well. Don't know what level that comes up on camera. It's got a little beeper in there. I'm not sure what volume I've got set to this actually. Might be the volume's a bit low. Let's see, let's find out. System, sound, level 1, level 2. Yeah, so level 1 is quite quiet actually. Off. Okay, so I might do level 3. So back into measure again. That's on holding. See, remember the last memory we used? Alright, so now you can hear it now. It's definitely a lot louder now. Still fairly quiet though. But obviously the buzzer is going to be quite small. So it will basically hold on the last reading. So if I get the calibration board for example, so if I go into the calibration thing here, so it beeps when it's got a stable reading. So you know it's got well, it's sensing a reading at least. And it holds it on the display. Alright, so you know it's actually done a hold and it's got something. It's actually taken a measurement. Okay, so it actually shows you that. And it holds on display, so you don't have to keep looking at the tweezers while you're doing something, you know, like if I was trying to, say, probe this capacitor here. Alright, there we go. Capacitor reading. I think the longer you leave it on there the better. Give it a chance to take a few readings, gives it a chance to stabilise. But But anyway, so that's what the holding one does, which is quite nice. So below hold we've got cal. So you've got self cal, open and short calibrations. Right, so you should do these periodically. And that's also part of the calibration board. There's also a factory calibration, which is, if you've got the right tools to do the job, you can do the factory cal. I don't recommend playing with that unless you actually have high precision references to use to do calibration this thing. I don't actually know what it requires. Maybe Shannon can tell us. It'd be nice to actually know what it requires to do calibration. I don't want to go in and messing with it and find out break it or something, or mess up the calibration, not have the right things to do the job. So that's that, and then we've got shut down as well over here. So that means you can drop it in there and it will do a little warning. So if you want to cancel, you change your mind, you can actually come back out. It does the same thing, it does auto power off. I'll show you in a second. It's going to wait for it to do that, which will take 30 seconds. So we're just about there. There we go. So I'll do that and it's turn itself off. Done. That's that bit. So something I should show you in the system menu. I'll go back in. So system menu, service, that's further down, right? So you got the display which you showed before, service. You go in here, it tells you information about the battery, so it tells you the battery voltage. System, service, version. So it tells you information about the actual unit. So it's got firmware information, things like that. So this is using 1.3.8 right now, and that's an older version of the firmware. So this obviously is current when it's sent to me, but there's now a newer version which is 1.4.2. I actually tried to install that on my Mac because I use a Mac computer. I may mention this before, and Macs tend to be not so well supported in lots of situations. Now there is a firmware update available for the Mac system, but it seems to be it requires a newer Mac system or something like that. I'm not quite sure exactly. Although there is a firmware update, I can't do it on my Mac currently. I've raised a point on the EV blog forum where Shannon's got a big thread on there about this particular product. I mentioned that I wanted to do the firmware update on it as part of this review and show how to do it, but I can't do it. Now other people have said they've had no problems doing it because they've done it on PCs or under Linux and stuff like that, so that's fine. It's supported nicely under those systems. My Mac, although in theory should do it, it depends on certain criteria of the system setup. So I'm using an older Mac on an older operating system because I've got software constraints, things which means I can't update. So that may be causing me some problems with the reason why I can't do it. Other people on a newer system might not have any problems. But what I will tell you is that when you do that, what you're supposed to do is hook the USB port up and then you hold this up, something like that. But once the USB port's plugged in, then it goes into like the firmware flashing mode. But you have to have the USB plugged in first, so it's got power through there. But yeah, I mean, I will do it eventually. I'm hoping that Shannon's got a fix for this particular situation where I want to flash this thing. Maybe I can do it in Arduino IDE and upload as a bin file. I've got no idea. I'm not that familiar with doing that kind of work. Flashing things isn't something I normally do. It may be a simple fix that I'm just not aware of. It's entirely possible. But I know other people said, yep, just use a Windows machine and did it on that, then it's fine. So yeah, it's updatable. There is firmware updates, just do it through USB port. The newer firmware does have some improvements to it, some tweaks to the menu system and things like that. A couple of little things how it works as well. It's quite good that it's doing ongoing development on this thing. That's enough waffle, let's actually use it, shall we? So this board here is something I'm currently trying to repair. Something is wrong with it. I don't know what yet, I'm still trying to figure that out. Tweezers are on, got it set to auto mode. Let's just do some random measurements. Just do it so you can see what I'm doing. Hopefully. My eyesight's going to be more of an issue than anything else, I think. So there's a 1K resistor, 93 nanofarad caps, probably 100 nanofarad. This is set to 10 kHz right now. 41 picofarad in that one, but then I've got a measuring cost of resistors, probably some other circuitry around it. Now this actually has a bit of oxidization on it, so it does make it a bit hard to probe through. Hard to break through the oxidization, so 42 nanofarad for that cap. You know, it's like probing around. 8.24K there, 8.24K there. And if I change this frequency, does that change anything? 8.24 still. Let's measure this capacitor again. There you go. It's changed a little bit. Am I actually on it properly? Yeah, 95 nanofarad. I was getting in. There we go. So yeah, frequency does affect the readings on these. I can get across all these things here. You know, there's some diodes here. Let's measure a diode if we can. There's probably some other parts across them which might cause some problems. Let's measure something else. Measure in the other way. Yeah, I've got some parts across there, so it's measuring the resistance across there. There's these things, which are Zenas. Let's try that. Try it around. Nice parts there causing problems. If you have lots of issues, you may actually need to do manual modes, which I might try in a second. Yeah, I'm just getting resistances there. So let's try doing a manual mode. LED, diode. Okay, I don't know if I actually have to swap it around or not. I don't actually know. There we go. So that's giving us 2 readings there for the diode. See that? Forward and reverse. Let me get closer. So it actually gives you both readings at once. Maybe I don't actually need to swap them around after all. There we go. So getting 0.52 and 0.74 forward and reverse. So it's actually measuring both directions at once. That's nice. I'll check the other one, see if this does anything different. That's the same. So I'll measure these Zenas again. Forward voltage 0.52. So it shows you both voltages if it can see both voltages. So let's do LED mode, which is that way. So there are some LEDs on here. I don't know if I can actually trigger these or not. I can't see them lighting up, but it says 0.8 volts forward voltage. I'm not sure that's right. This one here says 0.8 volts as well, with a current of 0.18 milliamps. Is that adjustable in any way? Don't know. But it's not lighting those ones up anyway. Yeah, another diode doing the same thing, so it's not lighting them up. Maybe we need some different LEDs. So I sort of go into another mode here. Got DC resistance, which I didn't really look at before. I was using auto mode, which is doing like a reactance, is basically AC measurements. Let's do these resistors here again. 10.7k. And go on that one. 8.15. So there's obviously something around the affecting them. Before they both did 8.24. This one's 220k. So that's different from before as well. That's doing AC measurements, now it's doing DC measurements. So that's interesting. Auto mode again. So there's resistance again, but with frequency. This is AC. There's inductance. Do we have any inductors on here? I don't think we do. Apart from that big one. No inductors on here. Capacitance mode. So we also have that reactance mode. ESR. Let's look at ESR. So we've got some capacitors on here. Let's see if we can measure these. 17.5 ohms at 100 hertz. 19.2 ohms at 100 hertz. And 4.08 ohms or so, 4.07 at 100 hertz. That's at 0.1 volts. So let's try a different frequency. Let's go to 10 kilohertz. This should give some quite different results. Try not to touch the probe myself with my fingers. 6.5 ohms. It's dropped quite significantly. 4.9. Well, it's changed quite significantly. And 2.9. So yeah, that did affect it with frequency. Back to auto mode. Let's change the voltage to 1 volt. So 17 ohms again, 100 hertz. 19 ohms again. And 4 ohms again. So yeah, the voltage didn't affect it in this case. But it would affect some other things, I'm sure. So on diode mode, let's see if I can measure this bridge rectifier here. Right, it's diode. It's saying it's a short. When I know it's not. And I measure the other way, on this side. Get onto it again, it's got a bit of a oxidization residue on here. That's also saying it's a short. Now I know that's not correct. So I get my Fluke multimeter here and I measure there to there. Diode junction. Other way. Open. Diode junction. other way, open. So this is reading correctly on that. So this for some reason doesn't like the diode bridge. So that's interesting about why it doesn't like that. I think we need to test some more diodes with this thing, because I'm not convinced that's either me using it correctly or something else going on there. Maybe it's got some little firmware bugs maybe. Again, like I said, this isn't the latest firmware. It could be these things are full fixed in the next version, I don't know. So let's get some more diodes. Right, so we've got a 4007 surface mount device and a diode bridge. Just try these. That's showing 0.5 volt drop across the diode, which is correct. Turn around the other way in case it matters, it's not showing up. So maybe polarity does matter on diode mode. Okay. Back around the first way. It does. Okay, so it does actually care about polarity. So let's look at this diode bridge. I'm not sure which side's which. There's the AC side here. So let's just go across there. Nothing. And let's go diagonally if we can. It's going to be a little bit tricky. There you go, it's measuring that fine. Okay, diagonally on this one. Open. Reverse the polarity. 0.5. So it is actually measuring the bridge just fine. So maybe it's something about the in-circuit aspect of this, because it's got a bunch of circuitry around it, other capacitors and stuff like that. Maybe it's upsetting it. It's possible. I just realised I had it on LED mode, not diode mode. But anyway, let's just do that again just very quickly. See if it changes much. It still shows up top there. Doesn't seem to matter. It's basically doing the same thing, showing the forward voltage drop. Put it backwards. Yeah. I don't think the polarity matters. No. So in diode mode, polarity doesn't matter, but it does tell you which way it is. See this arrow? It's giving you forward voltage regardless, but the indicator on the screen changes. So now it's pointing downwards. Turn it over, now it will point upwards. See? So it does actually tell you which way around it is. Okay. So that is working fine, that one. Need some LEDs. I'll just fish myself out a small inductor. Let's turn it on again. So it remembers the last mode you used too, which is quite nice. So if you use a particular mode all the time, you might want to use that. So here's an inductor. Let's see what this thinks of it. 480 microhenry. Nice. You read it just fine. Excellent. So I'll grab the colour of LEDs. We've got a standard red LED. Nothing that way. I've got an LED mode this time. Now, oh, it's flipped off. So that is indeed lighting the LED up. Maybe we can see it on camera. So it is lighting it up. This is 1.74 volts. Okay, and then we've got this white LED, which is like an ultra bright one. Nothing that way. Turn it around. That way. Oops. You can see it lights up pretty well actually. It's really bright actually. And that says 2.56 volts. So it's actually working quite well. This doesn't like the in-circuit stuff for some reason, which is interesting. Right, see if we can measure this capacitor, 2200 microfarad. Always make sure to discharge before you hook up to these things. Let's have a look. Oops, I just turned off because I was waiting too long. Might need to increase that timeout a little bit. Okay. Auto mode. Can it do it? Let's get in there. There you go. So that's just under 2000 microfarad. That's at 10 kilohertz. Let's change the frequency. 100 hertz. Test it again. It gives the same reading. Let's increase the voltage. Half a volt. Slightly higher reading there. Bit more erratic, interestingly. Also shows series resistance of 29 milliohms. Let's do an ESR on that one, which is here somewhere. ESR. There we go. See, it gives the same reading. About 26 to 29 milliohms or so. At 100 hertz, at half a volt. Let's change the voltage again, do 1 volt. ESR's very slightly lower. Okay, back down to 0.1 volts. Yep, 28. So that lower voltage actually at 0.1 volt seems to work quite well. And that's 2200 microfarad. Nice. So here I've got a 10,000 microfarad cap, 35 volt. And it can read it. So 10 millifarad basically is what it is, and that's skewed 9.1 with 30 milliohms. So if I do this in circuit testing on this one, I can't tell you what the values actually are because I can't read them because they're obscured. So 9.5 microfarad, so that's probably correct. It's probably a 10 microfarad. 407, so it's probably, oh, what's that could be? Probably could be a 470. What's this one here? It's 413. And this one here, 29. 54 ohms, that one. This one here is measuring 230 milliohms, 220 milliohms, and 11 ohms. So this one's slightly high actually. That's interesting. And yet both those middle caps are 470 microfarads. I can't say what this one is. I can't quite read it. It's obscured. So it's saying about this tweezers, right? So there's no voltage measurements on this thing. Some tweezers do voltage measurements to some degree. This is basically a LCR meter. Just stick this on the bench and measure it this way, because I'm trying to not have my hands affect the reading. Can it tell me what this is? This is a 1 microhenry inductor. Can't do it in auto mode, so let's go down to inductance. It's getting pretty close there. 750 or so. It's got high voltage, high frequency. Here we go. Higher frequencies bringing it out. 1.3 microhenries, and that's pushing on the bench. This might be affecting it as well. Let's change voltage again. It's 1 volt. Does that? 0.1 volt. It works fine. So if I can actually kind of hold this and have it not on the bench. Here you go. Yeah, 1.3 still. So yeah, I mean it's could detect a 1 microhenry, but you have to go into inductance mode manually, which is fine I suppose if you know that's what you need to do. Now also, I haven't actually done the calibration on this thing yet, so maybe I should do that, because that may well affect some of these things we're doing here. System, is it? Oh, I'll put it under measure, is it? Measurer. Speed, hold, cal. There's cal. So I might as well show you. Yeah, it's doing a self cal. So let it run through. Maybe I'll measure that in Datron again, make sure, because it might affect the reading. Probably should have done this before I started. Okay, that's that one. So what's the next one I need to do? Let's go to the system. I want to go to measure again. Cal, cal. I want to do a open cal, do that. It's a particular way you're supposed to do this. I think I'm supposed to have it on the board, aren't I? I think I'm supposed to have it on the board. Open, yeah, there we go. Open cal. So you got some kind of thing around it. I guess it may matter. Let's try this. So, measure, cal, open cal on the open cal pads on this board. In case it matters, it probably shouldn't anyway. Okay, that's that done. And then we've got a short, which is there. So I do the same thing again. Measure, cal, short. Stick it in there. And cal that one. Okay, so that's now calibrated. Let's check that inductor again. Yeah, it's about the same, 1.3. No difference. So if you want to find out more about these things, definitely go and check out the links down below to the Shannon Tweezer website. You can download this thing off the website, it's up there, you can get that, get the firmware and the link to EV Blog Forum, which has got currently 7 pages of information about these things throughout the development and suggestions people have made about ways to improve it. I mean, Shannon does appear to be open to suggestions and taking on board things which people have thought maybe it could be changed slightly in a certain way, and they have been adding those over time, which is why there's a 1.42 version of the firmware right now where I've got 1.38 on here. So it's gone through like 4 revisions or 4 changes from other people's suggestions on the website, you know, so it's quite good that they're actually taking that sort of stuff on board. It seems to do out of circuit component testing perfectly fine. I don't know what the specs were for like resistance and stuff like that. It does actually have all that information somewhere. I don't have it here Obviously go down to milliohms. Yeah. I should really check this on my calibrator and see what it thinks of it actually. How can I do that? Seems as a tweezer. So I tried this thing on the calibrator. I put it on the DC resistance mode. I started off as an open, then I went straight to a short on the resistance mode, and this kind of locked up. I did actually eventually get a reading like 100 ohms, and then that sort of stuck on the display, and even when I went out of that mode and into other modes, it didn't actually recover. That was quite interesting. It's got like a bit of a bug there somehow. So anyway, I went into this resistance mode in this one here, and this one was working fine. So it measured with a 200 milliohm offset based on my calibrator, because that's the lead resistance and the resistance for the calibrator and sort of stuff. So if I shorted the leads directly on the input to the calibrator, it was like 17 milliohms. That's lead resistance. So lead resistance is 17 milliohm. I've got like 200 milliohms for the calibrator. You know, okay. So English as well. So that was out by about 200 milliohms, and I was doing those measurements. So it did up to basically 100k. Okay, 100k was slightly off, but it's like 200 ohms off at 100k, and 1 mega ohm, it couldn't really read it. I think it's just too much electrical noise around here is affecting the readings too much. It was trying, and I did the DC resistance mode. It's slightly better, but it still struggled. I couldn't really read 1 mega ohm. I think it just couldn't really generate the current. So I think that's part of that problem there. So doing high resistance measurement on it is probably a bit tricky unless you're in a particularly quiet environment. So how I hooked this up is I actually put some banana leads into my calibrator front panel, into the terminals. I don't know, about that long, there's some banana cables, and they've got crocodile clips on one end, so I put the crocodile clip on these here. So that's where I was getting that connection from. But I mean, it did work. I mean, 1 ohm up to 100k were absolutely fine. You know, certainly well within acceptable limits. And the 1 mega ohm was struggling with that because I think it's just too low a current for that. It did kind of show 10 mega ohm. I did see out like 3 mega ohm on here. The display will actually show giga ohms on the display, but I think you need a really quiet environment to be able to do that sort of measurement because there's too much noise here. So at the very beginning I sort of flashed this particular tweezer up as a comparison. Alright, so I had this one for a while. Now there's a big difference on this. I don't know if you can see it on camera or not, but there's a lot of slop in these tweezers. Right, so this is the, what brand is this thing anyway? It's a whole peak. You can see how much slop there is in our tweezers, right? So much they move. Right, just not very nice. There's a lot of movement in there, and it's without even really trying it much. Whereas I'll do the same sort of thing on this one, the Shannon Tweezer. Right, actually trying to twist it, there's hardly any movement whatsoever. Much better. So the difference between this thing, which is really cheap, it's well relatively cheap to get, is obviously that. You also got these connections in here, so you can put banana leads in this thing and hook up these to use it as a multimeter, I suppose. This can measure voltage up to 36 volts. You can also do some Xenon diode testing, which is why I've actually kept this thing around, although I don't really use it, to be honest. I think I've used the thing a couple of times, and I've had it for a few years. And it does LEDs and stuff like that as well, do these different modes, but it's on this switch, manual switching. I haven't got batteries in it. Keep the batteries out of it. You never keep batteries in things you don't use very often. Otherwise you go to use it and find that the batteries are leaked and ruined it. Yeah, I mean, this is bulkier, as you can see, it's significantly bigger. Right? It's going to be a lot heavier because of these big batteries that go in it. It's more clumsy to use, it's obviously longer, the tips aren't as nice, it's a lot more sloppy, it's really hard to grab hold of things on this one. So this one is, although it's significantly cheaper, it's not as good. It doesn't actually have LCR functions on it either. It's not LCR. Whereas this is basically an LCR meter. It is an LCR meter. It tells you inductance, capacitance, resistance. You know, it's called a Shannon Tweezer, but it's an LCR meter. It does alright. These aren't cheap. The idea, I think, with the original project from Shannon was to have these as a low-cost tweezer. But I think once you actually go to sort of trying to generate this sort of quality, the cost will increase. Now, they do actually have different options on the website and on the, I think it's sold through AliExpress actually, so AliExpress links up there for that. And they've got different packages you can get. You've got this plain tweezer like this in a box, or you can get different options like I've got the leather case of this one, and you can get the calibration board with it as well if you want. They've got a few different options. You get one with spare tips as well. That's also available. I think you can get spare tips from themselves as well now, because that was suggested by someone on the UV blog forum to sell the spare tips, and they've actually added that. I mean, obviously there is a price-performance balance you have to try and meet. These aren't cheap, but they're not that horrendous really. You know, they're actually alright. Considering what these things do, to be honest, I would buy them. Obviously I've got these at no cost because it's for review, so it's a bit different for me, but I would have actually bought these, I think, because of what they do. I mean, this is a LCR meter. It's just a really, really small one. Yeah, so this tweezer is significantly better than this whole peak one. It's definitely a lot better. I don't know how long the battery will last on it, because we'll find out. This is the sort of thing I would actually have on hand. I'd stick this on the side of my desk here and just have it on hand. Because sometimes you want something just quickly check. I mean, sure, you can get your multimeter out and stick your probes on there and use your fine probes and things like that and dig into it. But sometimes you just want to do a little quick check, and something like this might be quick and easy to use for that. I'm sure I'll figure out more as I go along about what features I use these for. But they look like they've got a lot of promise. I mean, there's a brand new out there. So go and check out the links down below to Shannon's website and buy one through AliExpress as well. Catch you later.